Millions of kids are curious about STEM. Let's simplify that. Watch Simplifying STEM with Sirisha.
Right.
Edgar, thank you for being here. I know you work in the semiconductor industry. Maybe you can introduce yourself.
Yeah, sure. My name is Edgar. I work in the semiconductor industry. I've been working for 3 years. I'm a process engineer, specifically in the plasma etching.
And what does a process engineer do?
And so, a process engineer is somebody that monitors, controls, and optimizes processes, specifically for the semiconductor industry, just related to the manufacturing of micro devices, while also ensuring safety, sustainability, and cost effectiveness.
And what is a process? For someone who's trying to understand what that means.
Right. A process is pretty much an operation that either I can put it in semiconductor industry terms, which is either adds or removes a certain step needed for the building of the semiconductor devices. It's typically a single operation, and there's different types of processes within it. There's lithography. Within lithography, there's different operations there, such as post baking, exposing, photosensitive films. In plasma etching is actually the etching using ions and electrons in order to be able to create a specific feature in the micron size level. So, yeah.
Very nice. So what is your typical day like? What do you do every day?
Yeah, so every day I check my process control charts. That's the first thing I need to do, and I need to make sure that they're within the specifications that are set. After I do that, sometimes maybe there's a batch or a specific product that's halted in the line, and so I have to go and check and make sure to be able to follow up with the necessary actions for that specific batch or product. And I need to be able to either send it on or keep it on hold or further investigate based on whatever is needed. After that, I probably do a lot of. I have several meetings, and those meetings are for long-term and short-term projects. So there's always continuous improvement in the facility, and so those meetings kind of help us either improve yield, reduce waste, and it requires a lot of coordination from different groups in order to be able to come to the best decision and improve the situation if needed.
So when you say improve yield, you're for someone to understand.
Sure.
Semiconductor device is actually built on a wafer, and
Right.
you want more of those chips on a wafer to work.
That's right. Yeah, there's tens of thousands of chips in a wafer, as you were alluding to, and you want to make sure that you get many of them as possible. And there's hundreds of processes in order to yield a wafer, and so you want to get as much of it as you can for cost effectiveness.
So we started with one of the first questions was, what do you do? But can you physically talk about the environment that you work in? Maybe how you dress? What does the setup look like?
Oh,
For
yeah,
someone
sure.
to visualize how their life, if they were to work,
Right.
what the day would look like, or a couple of days, because I know probably every day isn't the same.
Right. So I show up to work probably like this. This is how I just go into my cubicle and I start my work and I check my charts. Then we have to go into what's known as a clean room. That's where most of the tools are. And the reason that it's a clean room is because we have to have a very low defect density, not a lot of contaminants or particles in the air. Then, so for me to go in, I have to wear a bunny suit, which we call like a bunny suit, which is pretty much just a clean room gown. Your face is covered, you have protection on your eyes, and then you get ready. You have gloves on as well. The number one contaminant of semiconductors is probably human sweat or something, so we want to make sure that you're covered. Then after that, I'm able to go into the clean room facility, into the fabrication plant, and there all the tools are lined up in specific order, so that it's easier at an industrial level to be able to access them. You don't want them scattered all over the place. You want your tools to be in a pretty much the same aisle, the same row. Within there's operators that are moving the operations through. We have operators that help move from operation A to operation B, and once we're there, I can, if a tool's down or if a lot is stopped, I have to go and inspect it. Inspection is the first thing to determine what something could be wrong. Checking maybe the logs, the history logs of the tool is also very important. We have ways to also monitor that externally with the charts. That can also sometimes tell me what specifically went wrong, power, gas, cooling, things like that, which are all important for what a wafer needs to do to process. I just wanted to make that clear. And yeah, once I'm in the fab, I investigate, I follow through. You want to just definitely use the scientific method to try to like solve the problems. You want to use engineering methods. Sometimes you could do testing remotely as long as you have the proper automation set up as well. So you can also do that remotely. But yeah, that's how it looks. I'm splitting time between my cubicle and the fab. It's a lot of that.
Good. And so what can one step someone take?
I think learning about semiconductor devices is probably the thing I would say the most. It's something that I wish I would have done earlier in mine, because I was always kind of like interested. But I would say, learning about semiconductor devices, microfabrication is also another one. Audit a class, volunteer in a lab. Those are pretty good first steps.
Someone in middle school and high school?
Robotics. I volunteer a lot in the robotics STEM outreach, and those kids are sharp, and you learn a lot. You learn all about coding. You learn about like what moving parts there are, engineering methods. I would say join robotics. That's been something that I've noticed that have been very helpful for students in middle school.
Yeah, with that note, thank you so much. I think that's very good advice. Clubs, if you have, robotics, if you have available, or
Right.
ask your teachers and try to start one in your school.
Yeah, definitely.
Thank you for watching. And if you're interested in learning about more STEM careers, check out the link in the description below. And maybe there is a career we haven't featured that you are interested in. Please contact us. We would love to talk about it more. And don't forget to check out our next video.